Welcome to Kodesh Virtual Schools, where learning comes alive from the comfort of your home. Our platform provides interactive lessons tailored for all ages, ensuring every student thrives.
It becomes a waiver mountain. Now it's a river flabber.
Explore our lessons and become a better student with excellence results. Join a community of learners and access resources that enrich your educational experience. Sign up today and start your journey with Kodesh Virtual Schools.
Alright, good evening, students. Shout out to all our students all over the world. Good evening and welcome to today's class. And if you are new in this channel, do well to like, subscribe, so that you can get turn on your notification bell, so that you can get notification when we post new content. So we did thank you for joining us, and we also give credit to the material, the resources we are using. New School Chemistry, written by New School Chemistry. So we are grateful for these resources. It's amazing. So that's what we're using to educate. Okay, so let's dive into what we have today. We have our topic for today. We have bases and alkalis. In our previous class, we considered the concept of acid bases, the acids, and we said an acid is simply a substance that has the characteristics of being sour when tasted. It has the ability to turn blue litmus into red, and so on and so forth. And we looked at the various types of acid. We have organic and inorganic acids, and we look at the concept of ionization, where we say that when acid dissolves in water, it produces hydrogen ion as the only positive ion. Okay, and we also looked at the concept of basicity of an acid, which refers to the number of it refers to the number of hydrogen ion that can be replaced by metallic ions. We discussed all that in our previous class. Make reference to our previous class is in the channel. Alright, let's dive into today's class. Bases and alkalis. Bases and alkalis. The term base was originally used to describe substances that turned red litmus blue and neutralized the properties of acid in aqueous solution. Okay, so we'll go again. So a base is simply a substance that has the ability to turn a red litmus to blue. Meanwhile, acid turn blue litmus to red, while base turn red litmus to blue, and it neutralizes the properties of acid in water. Aqueous there is water solution. So it means that the capacities of an acid, the abilities of an acid in an aqueous solution is weakened and neutralized by the presence of bases. Okay, most oxide and hydroxide of metals are bases. Most oxide and hydroxide of metals are bases. Common example of basic oxide are sodium oxide, that is Na2O, potassium oxide, K2O, and magnesium oxide, MgO. They are formed when these metals burn in air or oxygen. E.g., we have this formula here that we see here. So when there's a combination of sodium plus oxygen, it produces sodium oxide. Okay. So most of these metallic oxides are insoluble in water. The word insoluble there means they cannot be dissolved easily in water. They are insoluble in water. However, dissolve in water to form hydroxide. So when they are dissolved in water, even though they are insoluble, when they later get end up dissolving in water, they produce what they call hydroxide. For example, like we have here, sodium hydroxide. Sodium Na2O is sodium plus H2O, that's water. You give us sodium hydroxide. The next one is also have potassium hydroxide. Okay, that is potassium plus hydrogen equal to potassium hydroxide, aqueous. Now A soluble hydroxyl is known as alkali. Now, a soluble means something that can dissolve in water. Okay, so they are saying here that a soluble hydroxide is referred to as an alkali. So an alkali is a soluble hydroxide. Oh, that is clear. Now, many basic hydroxide like copper hydroxide, CuHOH, and aluminum hydroxide are insoluble in water. Insoluble, like I explained earlier, they cannot be easily dissolved in water. They are insoluble in water. The few soluble hydroxide, like the hydroxide of sodium, potassium, and calcium, are economically important. The few soluble hydroxide, like the hydroxide of sodium, potassium, and calcium, are economically important. So I will take it again. An alkali is a basic hydroxide which is soluble in water. An alkali is a basic hydroxide that is soluble in water. Now, listen, let's carry on. Like acids, alkalis may be strong or weak. So there are strong alkali, there are also weak alkali. The same way we have strong acid and we have weak acid. Sodium and potassium hydroxide are strong alkalis that ionize completely in aqueous solution to produce negatively charged hydroxide ion. Now I will take it again. Listen carefully. Sodium and potassium hydroxide are strong alkali that ionize. Remember, we talk about ionization. The process by which a base or an alkali dissolve in water to produce what? This one is producing a negatively charged hydroxide ion. Okay, it produces a negatively charged hydroxide ion for base. Okay, so the ionization of an alkali is simply the process by which alkali dissolve in water or in aqueous solution to produce negatively charged hydroxide ions. Right. And positively charged metallic ion, so it produces negatively charged hydroxide ion and positively charged metallic ions. Calcium oxide react with water to give a hydroxide which is only slightly soluble in water. A calcium hydroxide solution produces relatively few ions. It is a weak alkali. So a calcium hydroxide is a weak alkali, not a strong alkali. So you have the chemical formula here given. Yeah. Another common alkali is aqueous ammoni, which ammonia formed when ammonia is bubbled through water. When ammonia bubbles through water, it forms ammonia. It forms aqueous ammonia. Aqueous ammonia will ionize to a limited extent in solution to liberate ammonium ions and hydroxide ion. I'll take it again. Aqueous ammonia will ionize to a limited extent in solution to liberate ammonium ions, that's NH4 with a positive charge, and hydroxide ion. Hence, aqueous ammonia is also a weak alkali. Let's carry on. Neutralization. That's our next topic. Neutralization. Remember, we say that alkali neutralizes the acid. All right. So let's carry on. Okay. So an acid turns blue litmus red, and alkali reverses, turns red litmus blue. If an acid such as hydrochloric acid is gradually added to an alkali such as sodium hydroxide, for example, there will come a stage when the solution becomes completely neutral to litmus. That is, the litmus becomes purplish, indicating that the solution is neither acidic nor alkaline. Only a salt, in this case sodium chloride, and water are formed during an acid-alkali reaction or neutralization. Now they are saying here that when acid has the ability to turn blue litmus into red, while alkali, which is a base, turns red litmus into blue, right? Now we know to say that if you add an acid, which is hydrochloric acid, into a base or into an alkali such as sodium hydroxide, there will come a stage when the solution becomes completely neutral. That means it will neither turn the litmus to blue or red. It will turn into another color, neutral. Okay? Now, we are saying earlier that when this happens, that solution is neither acidic nor alkali. I got that I'm saying. Alright. So it's here. We have an acid, we have an alkali plus salt will give us it's going to completely give us what? A salt. So we say that only salt, in this case sodium chloride, and water, yes, are formed during an acid alkali reaction or neutralization. Okay. During the reaction, the hydrogen ion from the acid is neutralized by the hydroxide ion from the alkali to form the water molecule H2O. Alright. So neutralization is a process in which an acid reacts completely with an appropriate amount of an alkali. When an acid reacts completely, okay, when an acid is completely neutralized with an appropriate amount of alkali or any other base to produce a salt and water only. So when an acid is neutralized by an alkali, right, it produces salt and water only. Or neutralization is a combination of hydrogen ion and hydroxide ion to form water molecules, yes, H2O. A salt is formed at the same time. So you can define it also as the combination of hydrogen ion and hydroxide ion to form water molecules and salts. That's awesome, right? Let's carry on. Now, based on this definition of neutralization, a base may be defined as follows. Now, this is what a base is. So, a base is a substance which will neutralize an acid to yield a salt and water only. A base is a substance which which will neutralize an acid to yield a salt and water only. Now we'll look at oxonium ion. Oxonium ion. Now, experiment indicate that in an aqueous solution, and I say aqueous solution, I'm referring to water solution, okay? So, experiment indicate that in an aqueous solution, the hydrogen ion become associated with water molecule to form the oxonium ion. So this is oxonium ion that you're seeing here, H3O, positive one. H3O is oxonium ion, okay? The bonding form is an example of a coordinate covalent combination. So we can see the formula there. During neutralization, an oxonium ion reacts with a hydroxide ion to produce water. Yes. Now, neutralization may also be defined as the combination of oxonium ion, this is another definition I've given us, of oxonium ion H3O and hydroxide OH, hydroxide ion OH to form water molecules H2O and salts. The existence of oxonium ion modifies the early definition of an acid. Thus, an acid is also defined as a substance which is aqueous, which in aqueous solution produces oxonium ion H3O as the only positive ion as well. So an acid is also a substance as is a substance which in an aqueous solution produces oxonium ion H3O as the only positive ion. The ionization of acid is represented more correctly as follows. So this is the ionization that you can see there. Similarly, the neutralization and acid trioxocarbonate 4 reaction may be represented in the ionic form as follows. So you can see the ionic form that we have here: hydrochloric acid plus potassium hydroxide equal to potassium hydroxide and water. When we have tetraoxosulfate 6 acid plus sodium hydroxide, it will give us sodium tetraoxosulfate 6 and water. Okay. Trioxocarbonate 4 reaction. So when there is combination of hydrochloric acid plus sodium trioxocarbonate 4, the result is sodium chloride plus water and carbon 4 oxide. Since the sodium ions and the chloride ions remains associated in solution, the reaction can be simplified as follows. That is a simple reaction that we have. Physical properties of an alkali. Number 1, alkalis have a bitter taste, meanwhile acid have a sour taste. Alkalis are soapy to the touch. Alkalis turn red litmus blue. Yes. Concentrated form of 2 caustic alkalis, sodium hydroxide and potassium hydroxide, are corrosive. They can damage your skin. They can affect your skin. Chemical properties of bases, that is alkali. Another name for bases are called alkalis. Okay. Reaction with acids. That's my one thing. All bases react with acid to form salt and water. All bases. You will be asked in exam. Bases react with acid to form dash A. So you should know that it's salt and water. Next one, reaction with ammonium salt. Alkali react with ammonium salt in the presence of heat. In the presence of heat to generate ammonium gas. The reaction can be used as a test for alkalis. Alright. Uses of alkalis. Alkalis are important substances used in industries concerned with the manufacture of glass, soap, paper, and rayon. Some alkalis are also used to soften hard water. So uses of alkalis that are used now: sodium hydroxide, used in the manufacture of soap, sodium salt, and plastic, used in petrol refining, sodium hydroxide. Number 2, potassium hydroxide, used in the manufacturing of liquid soap, used in dyeing and electroplating. And next one is calcium hydroxide, another example of base, used in manufacture of mortar, cement, and plaster, used in neutralizing acidic soils. Next one is magnesium hydroxide. This is used in manufacturing of toothpaste, used as a laxative. And next one is aqueous ammonia, used for bleaching clothes, used as a detergent. Alright. Yeah, so this is what we have today. Okay. I think this is where we draw the curtains for today. So when next we meet, we're going to carry on with the measurement of acidity and alkalinity. How do we measure acidity and what alkalinity? So remember, we say that acidity or basicity refers to the degree of acid or base in substance, right? So I'm going to see how we're going to that's actually pH. Yeah, pH scale. So the pH scale is simply the degree of acidity or basicity of an object, of a substance, of a chemical substance. The degree of acidity or basicity refers to as pH level. Alright, and we say that it ranges from 0 to 14. I got what I'm saying. So that of acid, the pH of an acid is from 0 to 7. Once it's above 7, it's no longer an acid but an alkali. So when next we come, we're going to look more deep into the measurement of acidity and alkalinity of measurement of acidity and alkalinity of using a pH scale. All right, so this is it from me. We have an amazing time. I really enjoyed this class. I hope you did as well. So do well. Remember, if you have any question, leave them in the comment section or reach out to me on WhatsApp, or you do well to reach out to us on our website or our email address. It will be attended to as soon as possible. The email address and the website will be at the description. So stay well, remain blessed. Goodbye for now. Thank you.